Hi, everybody. Professor Leach here. Today, we want to make get a little summary going of the progress we've made on our mystery problem. This is the problem where I told you to do a bunch of things, to choose a date, do a bunch of things to the month number and the day number, and then come up with a number. Then you told me the number, and I was able to figure out what the month and the day was based on your number. And then I said, this is simply some trick. I'm just doing some weird thing to the number that you give me to come up with a date. Let's try to figure out what that is. All right. Let's talk about some of the observations that you've made. So first thing I want to point out is that a lot of you have been setting up problems like this. You've been fixing one thing. So some of you picked I just picked the 24th the 24th of various months, ran it through the process, and noticed that the tens and the ones digit seem to be related to the day, because if you pick the same date, the same day in every month, it always gives you the same tens and ones. So the 24th will always give you a number that ends in a 9, whereas the second always seemed to give you a number that ends in 87. And then a little bit late after this, we've observed that the 17th always gave us a 2, and the 10th always gave us a 95. So the first thing we notice is that the day seems to determine the tens and the ones digit. Because if we just always pick the same day, we always get the same tens and ones digit. So those seem to be linked together. That's a great observation to make. Some of you have noticed that sometimes the hundreds digit is the month. So like here we have 309, 409, 809, 1209. Those all came from March, April, August, and December, and the 09 seems to be related to 24. But sometimes we have to add 1 to the hundreds digit to get the month. But then they raise the question, when? When does that happen? So sometimes we add 1 to the digit to get the month. So 287, 587, 987, and 1187 all end in this 87, and all are related to the second of the month. But now, where the 24th always gave us a 9, and in this situation, the hundreds digit, and sometimes the thousands digit, gave us the month, in this scenario, we had to add 1 to the hundreds digit to get the month. So 1187 corresponds to December 2nd. 987 corresponds to October 2nd. 587 corresponds to June 2nd. 287 corresponds to March 2nd. So first, we are doing good science. You're just holding one thing steady and supposing that and testing that hypothesis. If we pick the same date, is it always end in the last? Does that always correspond to the same last 2 numbers? And it looks like, based on this evidence, yeah, that seems to be the case. Here was another good one that came up. 300 was March 15th, 400 April 15th, 500 May 15th, 1000 October 15th. So it looks like the 15th corresponds to double aught in the tens and ones. And also be careful with this 300, this March 15 one. Beware that one. So the day seems to determine the tens and the ones digit. Question is still how. Sometimes the hundreds digit is the month. That is, we don't add 1 to it. And sometimes we have to add 1 to the hundreds digit to get the month. So all good observations and relevant to our interests. Here were 2 other great ideas, great observations that a few of you made. So other great observations. I don't know if this isn't really an observation. This is more of an attempt to understand the problem. So the first one that I really liked, especially because this is exactly what we've been doing in this class last couple of days, try to write an expression. So that was really cool. Some of you are looking at the expression cycle. Let's try to encode this in the math that we are working on. Makes sense. We're in an algebra class. Maybe we should throw some algebra on this problem and see what happens. Some of you are going to be reluctant to do that because it's algebra, and you're like, ugh, algebra. Why would you want to get algebra all over the problem? But then again, it is an algebra class, so that seems like a reasonable thing to do. So the process, if we can encode it, first I asked you to multiply the month by 2. So I take the month and multiply it by 2. Let's summarize what the process is. Then I said add 7 to the results. And then third, I think I asked you to multiply by 50. And then fourth, we add the day to the result. And then fifth, I asked you to subtract 365, I think. Yeah, subtract 365. And then we were trying to figure out the secret 6th step that I was doing to get at the month and the day. So some of you, a few of you in the discussion started to encode this process into encode this process. I did say that right. Encode this process into an expression. So you decided that you were going to say, I'm going to give the month and the day variable names. So let's let X equal the month and let Y equal the day. And we're just going to write an expression. So instead of having numbers that hide what's going on, let's just lay out what's going on. Generic month, generic day, and encode the process. And so you just started encoding the process, month. And I like this because this is exactly what we're doing right now in class, trying to figure out where the parentheses should go. So first step is to multiply the month by 2. So take the month X and multiply it by 2. So we write that as 2X. Next step is to add 7 to the result. So then add 7 to the result. And then this was what made me really happy. The next step is to multiply by 50, but the multiplication has to go after this plus 7. So that's when we need parentheses. So I'm like, oh man, it's like this problem was designed to make us do this stuff in class. The third step is to multiply by 50. Then we add the day. And I don't need parentheses here because that addition will come after this multiplication. This multiplication will come after the addition and the multiplication in these parentheses because that's what the parentheses are for. And then finally, we subtract 365. Although I got it fixed. Then we subtract 365. Once again, we don't need parentheses around what we had before, the result from before, because the subtraction will just come right after this addition. I don't need parentheses to differentiate that. And then it gives us our secret number. So that was an excellent, instead of writing the day though, I'm supposed to write Y. There, saved it. Just Y, not DY. So we have an expression for what the process is. So really, we could, instead of doing this, we could do this all at once because we have powerful calculating machines. So if I had a month of 7 or not 7, let's do 8, a month of 8 and a day of 24, I could just type this expression in 50 parentheses, 2 times month of 8 plus 7, close parentheses, plus the day of 24 is what I picked, and then subtract 365. I can get to the 809 all in one go. Or if, for example, I had December 2nd. So 50 times 2 times the month, 12, plus 7, close parentheses, plus the day, which was a 2, and minus 365. Oh, we get the 1187. All at once, we can go just have one expression to automate the whole process. There's our August 24 giving us an 809, and our December 2nd giving us an 1187. So thanks, calculator, for problem. So that was another great observation. I was really stoked when you tried to encode the problem, encode the process into a mathematical expression. So that was a really cool thing to observe. The other really cool thing to observe, one of you says, you know what, I'm just going to reverse engineer the process. I didn't give myself enough space. So the other cool observation observation, or I guess attempt. The other great observation, the thing that I liked, was someone just decided they're going to reverse engineer the process and just skip the ones that they don't know, that they didn't know. So the other great attempt was reverse engineer the process. So it's like writing the expression, but backwards. So let's write down what the process was. The process was take the month and multiply by 2, and then add 7 to the results, and then multiply by 50, and then add the day to the result, and finally subtract 365. Oops. There was still this last part of the process, which is what we were trying to figure out how to get from the number to the date. But the suggestion was just take the number and reverse engineer the whole thing. Now there are certain, so we can't reverse this step, the 6th step, because it's secret. We also can't reverse the day because we don't know what the day is. So we can't reverse the entire process, but let's at least reverse the steps that we can. So we're just going to perform inverse operations in reverse order. We're going to go backwards. We're going to start down here and go in this direction. We're going to do inverse operations. In reverse order. We're going to perform inverse operations in reverse order. We're just going to, and we're going to skip the ones where we're not sure. So add a day, we don't know what happened there. So we're just going to skip that one. And we don't know what the month is, but let's see if this helps us somewhere. We don't know what this last step is, so we'll have to skip that one. This is stormtrooper theory, where they're searching doors. It's like, well, if the door is locked, just move on to the next one. It's like, oh, dude, how are we going to find? We're supposed to find something. What if it's behind a locked door? Not just move on to the next one. So we're just going to ignore the ones. So we got to skip that step. So the first thing we're actually going to do is we're going to add 365. This is to the number. Add 365. I want to write, I'm not going to put that number, that one, because we're skipping it. Then the fourth part of the process was to add the day. But we don't know what the day is, so we can't subtract the day. So we're going to skip that. We're just going to do the ones we can, see if this helps us at all. So then the inverse of multiplying by 50 is to divide by 50. So divide by 50. That's how we undo that. And then this step here, the inverse of adding 7 is subtracting 7. So we'll subtract 7 at that step. We're just doing inverse operations in reverse order. Then the first thing that we did was to multiply by 2. So the last thing we'll undo is to divide by 2. We're just going to perform inverse operations in reverse order. Let's pick an example and see what happens. So let's pick 809. So we know 809 is August 24. For example, 809 corresponds to August 24th. So let's start with the 809. And let's see, well, we don't know what the last step is, but first we'll add 365. So 809 plus 365. And grab my calculator for this. 809 plus 365 is 1174. Then I'll take the 1174 and I'm gonna skip adding the day. I don't know what the day was, but I'll divide by 50. So I'll take the 1174 and divide by 50. Write that down, divide by 50. So 23.48. I don't want to round anything off. It's going to cause problems. So I'm just going to write the whole thing, see what we get. 23.48. And then we'll subtract 7. So somewhere this number still has the day in it, but we'll just keep following the process. 16.48. And then we'll take the 16.48, and the last step is to divide by 2. And that gives us an 8.24, which suspiciously has the August as the ones digit and the 24 as the tenths and the hundredths. So this should make us suspicious. So this is just one example of this seeming to work. So we're going to want to do this to see if this reverse engineering will actually do the trick. So we could do the same thing to, let's say, 1209, where we add 365 and then divide by 50 and then subtract 7 and then divide by 2. Oh, 1209 was a 1224. Let's see if it works on numbers from this other column. What if, because in this, if it was the second, we had to, like the second, it ended in 80, and the number ended in 87, and we had to add 1 to the month. So let's take 1187 and see if that'll give us December 2nd. So 1187, we're going to add 365, skip the day because we don't know what happened there, divide by 50, and then subtract 7, and then divide by 2. And 1187 drops us back to 12.02. So 1187 goes into the reversed steps. And landed us on 12.02, which we can interpret as December 2nd, which is what we expected it to be. So awesome. It seems that we have a process with these 4 steps that will reverse engineering the process seemed to work. Moreover, if we notice, we skipped the step where we add the day. So since we skipped the step where we add the day, we didn't subtract the day information seemed to stick around. So we skipped we did not reverse or invert the adding the day step, but the day information seemed to stick around. We didn't know how much the day added, so we didn't subtract it, and it seems to have stuck around. And that's pretty cool. And this seemed to work on both sides, where we didn't have to add 1 to the day, to get the month, and where we do have to add 1 to get the month. So that's another great observation. If I may embellish our observation a little bit. We didn't have to add, since we skipped subtracting the day information is still there. we skipped subtracting the day. Since we didn't know it. But that information is still in the number. So that's excellent, because we have a way to get from the number to the date. It involves these 4 steps: add 365, divide by 50, subtract 7, and divide by 2. So at the very least, we have a process to go from a number back to a date. So now we have a process to go from number to date. That's great. That's super progress. I will say this is not what I was doing to reverse engineer the number to the day, because I did not have my calculator. I didn't put myself on camera, and I was doing something else that is fewer steps than this. So that still remains a mystery. So we know that Leach cannot handle doing these 4 calculations in his head. You know that I can't do this. We know, you know that I can't do this. If you gave me a number, I would not be able to add 365, divide by 50, subtract 7, divide by 2. That's arithmetic, and I'm not good at arithmetic. I can't do 4 steps of arithmetic without asking the calculator for help. Right, calculator? Right. See, calculator confirms it. I can do one thing. I was doing 1 step. So that last step is still a mystery. But we have made lots of progress. The day seems to land, the same day of every month seems to give the same tens and ones digit. Sometimes we add 1 to the month, sometimes we don't. We have written an expression for the process using X for the month and Y for the day. And we've seen that we can reverse engineer the process just skipping over the numbers that we don't know. So instead of subtracting the day, since we don't know what the day is, we just don't subtract it. But it doesn't seem to matter, because that means the day information is still in the problem. And it shows up as the tenths and the hundredths. So it shows up on the right of the decimal point in 8.24. It's easy to see how we get August 24th out of that. And 12.02, easy to see how we get a December 2nd out of that. So even though we're skipping steps, the day information is still contained in the number. So the day information shows up when the process is undone. But there's still some other step that I'm doing, because I can't do 4 operations on a number. not without a calculator. Any questions? I'm really pleased with the progress that y'all made on this particular problem, especially this reverse engineering thing, because that is the next, so nice. Also, writing the expression, those of you like, oh, hey, let's just write an expression. This is an algebra class after all. And so you wrote the expression that we have here. This is also useful if you're going to examine, oops, where is it? There it is. Examine a bunch more days because you can just plug them into your calculator. So I guess the next question would be, so we've got this expression, it's kind of messy. It's just encoding all these steps. I wonder if there was a way to summarize all those. Any questions, comments, deep thoughts? All right. So tomorrow we're going to pick up where we left off last week on Wednesday. And we're going to talk more about reading and writing expressions relevant to our interests here. And then how we can rewrite those expressions in a simpler fashion. What is it that we can do to simplify the expressions that we're working with? Any questions, comments, or snide remarks? All right, that's going to do it for today. I'll see y'all on tomorrow. Thanks for playing, and peace out.